Okay, quick review. At some point, I asked you to memorize the unit circle. In the previous unit, we solved equations for x for typical problems such as these. So if you look, the sine of x is equal to root 3 over 2. Notice I specified that your answers all have to come from one revolution of the unit circle. So when you read this equation and you're thinking through what it is you should do, I'll take you through the first one and then I'll let you try to figure out the other two. The first thing is the fact that we're solving for x, which is going to be in radians. The next thought you should have is that sine on the unit circle comes back to the y value. So what I'm really asking you is, where on the unit circle do I have a y value that is positive root 3 over 2? The next thought process would be, well, y is positive in quadrants 1 and 2, so my answers need to come from those two quadrants. Where do I have a y value that is positive root 3 over 2? The taller triangles. So what are those two values in radians? X is equal to what? What are those locations? Oh, been forever. Pi over 3 and 2 pi over 3. Okay. So, as a heads up, you're going to have to clean the cobwebs out. This process, this mental process, is now going to be the last step of about 10 other steps. So this is supposed to be background working knowledge now. If it's not, you're going to need to practice and get that back under your belt, go back and review all of the unit circle definitions, etc. Okay? It's not going to assist you necessarily to have a unit circle out to look all of these up every single time. Yes, you'll get your homework done, but it's really going to slow you down because when it comes time for the test or as we go through all of these, you're always going to need a unit circle. It's like always having, like my algebra students, a multiplication table in order to do factoring. What are the two numbers that multiply to give you 16, but add to give you 8? 4 and 4, right? They have to go through the table and look at all the numbers to figure it out. Takes a long time to do factoring with them. All right, so please do the other two. If you want to work with your partner next to you, that's fine. Tangent of x is negative root 3 over 3. You're going to have to unrationalize that one, bring it back to unit circle values. And then also cosine of x equals negative 1/2. If you know the answers, you can just write them down. You may talk to your neighbor. It's allowed. There's no issue with that. Greg, Rover block today? Test. And Dalton will set it up then. Talk about it. guys too cold or are you okay? It's starting to like draft. I mean, there are 4 feet. Alright, let's start with number 2. Alright, step 1. Step 1, recognize, do I want radians or degrees? For x. Radians. Also notice my restrictions are in radians, so I'm looking for radians. Next thing I want to do is think about the ratio of tangent. Tangent is what over what? Y over x. Okay? Y over x. So what is this unrationalized? Meaning I don't have a root in the numerator. I originally had what? 1 over root 3? With a negative out front. And then what were each of the denominators if we knew they were unit circle values? They each had a value of 2, which tells me this is y and this is x. Now, another key idea is determining the quadrants. And what quadrants are tangent negative? Top left, bottom right. Okay. So I'm looking for the 2 locations that I have a y value of 1/2, which is a little bit of y, a whole lot of x, which are here and here. So what are those 2 places? 5 pi over 6 and 11 pi over 6. Next one should be fairly easy. Cosine of x, we're dealing in radians. Cosine goes back to the x value of the unit circle. X is positive in quadrants 1 and 4. So where do I have an x value that is, no, what am I saying 1 and 4? It's a negative, sorry. Cosine of x is negative in these 2. Puts me here and here. What are those 2 locations?
2 pi over 3, 4 pi over 3.
2 pi over 3 and 4 pi over 3. Any questions? All right. So here's a question for you. Erase this. First question. On the board on the far right, I have the basic graph of 1 period of sine, 1 period of tangent, 1 period of cosine. Do those graphs in purple pass the horizontal line test? So if I draw a horizontal line on any one of them, they only touch 1 time. Does horizontal line test work with sine? Does it work with cosine? No. Now, here's the trick. This is what you need to know. So if I draw a horizontal line here, notice it touches the sine wave twice. Okay? Cosine wave, it touches twice. Most of you are going to tell me that for tangent, it only touches 1 time, correct? The problem we have is that I only drew 1 period of tangent. Doesn't tangent continue to repeat numerous times? So if I have the repeated pattern, which maybe looks something like this, and I draw in a horizontal line, doesn't it touch the graph of tangent at more than 1 place? Yes. So basically what we're saying is all 3 of these fail the horizontal line test. What did the horizontal line test tell us? Yes. If function had an inverse, and if the inverse was in fact a function. Remember that one? The vertical line test tells you if whatever you had is a function to begin with. All of these graphs pass the vertical line test. But when they fail the horizontal line test, it means there is no inverse. So somebody came along and said, wait a second. It's really important that we have inverse functions. So instead of dealing with the entire graph, let's restrict the graph. So here's what I mean by that. For tangent, I'm only going to look at the area between negative pi over 2 and pi over 2. So if I take tangent and I say, okay, only between here and here, I'm going to cut the graph down and give you a restriction. So when I look at tangent, y is equal to tangent of x, and I tell you that it's on the interval from negative pi over 2 to pi over 2, if I just focus on that piece, which I have here in purple, doesn't that pass the horizontal line test? Yes. Okay. So we are going to define tangent inverse of x, also known as arctan. These are the same thing. These are your inverses on the interval from negative pi over 2 to pi over 2. All right, so first place I need you to check in right now is right here. Negative pi over 2. Most of you look at a unit circle and you see this as as 1.5 pi or 3 pi over 2, correct? But we're not. If you look at the graph, we're saying it's from negative pi over 2 to pi over 2. So we're going in a downward direction, and then we're going in an upward direction as well. So what I just highlighted in purple is going to be the inverse tangent function, where you can choose from. Okay? So these two are going to fall between quadrant 1 and quadrant 4. Now, the next one we're going to take is sine. Sine, we're going to do something a little wacky with it. We're going to actually go from here to here. We're going to look at the piece of sine that runs from negative pi over 2 to pi over 2. The red section that I just highlighted, negative pi over 2 to pi over 2, does that red section pass the horizontal line test? Yes. So over here, I'm going to talk about sine inverse, or what we call arc sine. It's also going to be defined in quadrants 1 and quadrant 4, and more specifically, it's going to run on the same interval as tangent, from negative pi over 2 to pi over 2. And then the last one, which is really the easiest, is cosine. Cosine is going to run between 0 and pi. So between 0 and pi, I have my cosine. So this is going to be quadrant 1 and quadrant 2 is going to be cosine. Inverse of x or arc cosine. And very clearly, specifically defining which quadrants I'm allowed to pull inverses from. You will never have answers in quadrant 3, ever. And the only time we use quadrant 2 is for cosine, the inverse cosine function. Now, personally, I just have a little acronym I always remember, and I always say that it's a sin to tan. This applies more, I think, to girls. I don't know. There are some guys that go to tanning beds, but it's a sin to tan. Sine and tangent have the same interval for inverses. Cosine's very simple. It's 0 to pi when you remember it. Okay. So all of the middle blah, blah, blah of your notes explains exactly what I just went over. On that left-hand side, do you notice the restrictions that are there? What you have in your notes matches to what I have is these little tiny like arrowed areas for tangent, for sine, and for cosine. Also, please take a note, look at your graphs for a second that are in your notes. Do you notice that along the y-axis you now have the radians, and along the x you have the actual like decimal values? We inverted them, hence the concept of inverses. All right, moving forward. Here we go. Tangents. I'm going to skip through all of that. All right, so I started to write this over here with notation for your introduction. There are two ways to represent inverses. One way is kind of the New Age way, which is where we use the -1, which is the same function notation we used when we were doing inverse functions. Arcsine is the older way. There's not really a difference in the two of them. They're just different types of notation for the same concept. Okay. So, if we move down here, cosine inverse of n, or arc cosine n, we are solving for a radian value. All right, so let's just do a couple of these problems. Your problems are going to look exactly like this. Tell me the arcsine of -1/2. What that means is that I want to know where I have a y value that is -1/2, but I have to do it in this interval between quadrant 1, and I'm actually going to kind of make this a little bit cheesier and say negative quadrant 4, or negative quadrant 4 for tangent. Because remember, we open downward into the negatives according to our definition of the inverses. So where do I have a sign that is -1/2? All right, well, my choices for sine inverse are quadrant 1 or quadrant 4 negative. -1/2 is going to put me right here. What is that location? And I'll give you a hint. It is not 11 pi over 6. What is that location if it is not 11 pi over 6? Remember, it starts at 0. You can go to -pi over 2 or up to pi over 2. -pi over 6. Okay. So those of you that have been sleeping, please check in and ask whatever questions you have about why that's the answer versus the problem versus what you're doing, etc. Look at it, think about it, and answer it. Yes, sir. Yep. Quadrant 4 will always be negative for these. Yes, sir.
It's negative because it would be for -1/2. Is that why?
No. Mathematically, that ends up being true for both sine and tangent. If sine and tangent are negative with inverses, it's going to be quadrant 4. Which means that the values you have to choose from basically are -pi over 6, -pi over 4, -pi over 3, or -pi over 2. You only have 4 choices down in that bottom half when we're dealing with inverses. Okay? It's not negative. Like, I don't want you to think negative means negative, although the association does hold true. That's not the reason why. It's because of how we defined where we chose our intervals. And I didn't choose these. They've been around for a long time. So, like, when you look at these, you think, well, why can't you just choose 0 or, like, from here to here? They could have, but they didn't. So, that's what we have. All right, example 2. Moving on. Oops. There we go. Sine inverse of root 2 over 2. So your thought process is, all right, sine inverse is defined in quadrant 1 or negative quadrant 4. So again, I'm here and here. Sine is the y value. So where is y? Positive root 2 over 2, which is here. And what is that in radians? Pi over 4 is your answer. Pi over 4. Example 3, now we talk about arc cosine. So in your brain, arc cosine is only defined, notice over there on the right, in the green section, which runs in quadrant 1 and quadrant 2. It's a restricted area. Arc cosine is negative root 3 over 2, which is somewhere over here on my unit circle. What is that value in radians? 5 pi over 6 is the answer. Yes or no? Does it make sense? I understand this chart helps you. The more you can start to memorize and move away from it. I personally think this is more helpful. I see this in my head. Anthony, you all right back there? Yeah? Get ready for a big Star Wars movie? No? Yeah, you.
Oh.
I know. I was just trying to connect. Gauge. No worries. All right, compositions. All right, so compositions mean this. We're going to start with some inside information, just like PEMDAS. So it's the same rules as what we did back in the prerequisite. We're going to build from the inside out. So if you take a look here, I want to know the cosine of the location where the arc sine is negative 1/2. What? All right, so don't worry about what all of this says. Start on the inside. Where is the arc sine negative 1/2? Go through the thought process. All right, arc sine is defined in quadrants 1 and 4. I want negative 1/2, so that puts me right here. What is that according to my inverse restrictions? Negative pi over 6. So now notice, that's what I fed in to this block that I solved for first. Now tell me, what is the cosine on a unit circle? What is the cosine at negative pi over 6? So what's the cosine at this location right here? Root 3 over 2. That's the answer I'm looking for. Start on the inside, substitute. Then answer the next part of the problem separately. Yes, no, maybe.
I don't get why you left the radians and then you went to like a coordinate line.
All right, let me ask you a question. What is the sine of 5 pi over 6? You were just having a conversation. What's the sine of 5 pi over 6? It's over there.
Yeah,
What's the y value over there? Sine is y.
it goes up 1/2.
Positive 1/2, right?
Yeah.
So one of the skills that we've worked on is just answering questions about the unit circle, right? What is the sine of it? What is the cosine of it? What is the tangent? The partner activities we did in the last, 2 units ago? Okay. What we're seeing now is that we're toggling between the ratios and the locations and back and forth. So the first inner part of the problem was, tell me the location that sine has that value. Then we got the location, and now we're going back to, okay, well, tell me the ratio at that new location. Does that make sense? You're going back and forth between these two things, and we're changing the ratio. So we started thinking in the vein of sine, but then we ended up having to switch to go to cosine, which is the x value there. So it's just moving between the ratios, basically. Let's do some more. Look at example 4 here. Don't be stressed out. Start on the inside. So I'm going to start here with this box. I want to know where the arc tangent is 1. In order to have a tangent of 1, what do you know about y over x? They have to be exactly the same. And tangent inverse is only defined in quadrants what? 1 or negative 4. So where do I have a tangent that's positive 1? Quadrant 1. The values have to be the same, so this is root 2 over 2, root 2 over 2, which is pi over 4. So now what I want you to do is I want you to tell me the sign at pi over 4. Answer? Root 2 over 2. I can't stress to you enough how important it is that you're flexible with your unit circle. You've got to have that knowledge. This is going to seem so daunting to you if you don't. All right, let's start by example 5. Time to check back in. Example 5 is a non-unit circle value. Write that down. Non-unit circle. Non-unit circle, non-unit circle, which means we're going to have to draw reference triangles. So, cosine is negative. Does that happen in quadrant 1 or 2? Quadrant 1 or 2? 2. So, if cosine is negative, it's going to look like this reference triangle. So here we go. Cosine is negative. Okay? Here is my theta prime, my reference triangle. I don't know what it is. I don't care what it is. Cosine is a ratio of A over H. Hypotenuse is here. This is 5. What's the opposite side? Two root 6. Is it 2 root 6? How do you get it? 49 minus 25 is 24, right? Square root of 24 is 4 times 6, 2 root 6. Okay. I don't want to be careful of that. All right, so now, once I've set up my reference triangle, which came from the information in here, I now want you to tell me the tangent of theta prime. What is the tangent of theta prime? Opposite over adjacent. 2 root 6 over negative 5. Done. O over A. It's back. Never went away. All right, before I turn you loose, I know we have 2 more problems. I want you to try the next problem in your notes. You can use your partner, whatever the case, but it relates back to this one. You have to set up the reference triangle in the correct quadrant. You have to watch the signs of the legs of the triangle. Then you have to answer the question that they're asking you for the new ratio. So go ahead and try the next example. See if you can draw it out, get it started. Think back at what we just did and apply it. right, I'm going to go over this without talking. And basically, after each step, I'm just going to do a thumbs up. If anybody shows me a thumbs down, then I'll talk to explain it. But when I do all the talking, then you don't have to think. So sometimes it's just a process of what to do when. And I think that if you kind of follow the process without me talking, it's helpful. Maybe I talk too much. I don't know. Are you ready? No. Hypotenuse is always positive. All right, so example 7 is another application of what we're doing. It just doesn't look exactly the same because what you're going to start on the inside with is actually like a question I would have asked you in the warm-up. So if I start on the inside, which the process follows the same, what is the cosine of pi over 6? So think unit circle, I go to pi over 6, I go over here, I say, okay, what's the cosine? Root 3 over 2, right? Cosine is going to be root 3 over 2 because it's the unit circle value. So I substitute that in, and I want to know then what is the arc sine? 3 pi over 2. Well, that's basically what we did in the example 1, 2, 3 in the early ones before we started doing these nested problems. So for arc sine, then I would say, oh wait, that's defined here and here. Sine is the y value, which is going to be up here. So the answer is going to end up being pi over 3 for the final answer. Okay? All right, you have the worksheet on the back. More of the same. Maybe start with the nested since it's fresh in your mind. There is one at the bottom that says something about like arc sine x. Just put that over 1 and assume that this is going to be the opposite and this is going to be the hypotenuse in your reference triangle. All the way at the bottom, you'll see like a variable by itself on the right. Yep, that one. Just put it over 1, and I'll give you the hint.